In this section, we are going to derive gravity of the suns. So we use this x and y coordinate, and the sun is located at the origins. Then x and y, this is x, y can be expressed r cosine f, and y is r sine f. From this equation, you can find x dot equal r dot cosine f minus r f dot sine f, and y dot equal r dot sine f plus r f dot cosine f. Then once we discovered x dot y dot, then you can substitute this r x dot here, y dot here. Then make a simple calculation. It becomes r square f dot. If you remembered Kepler's second law, Kepler's second law said r square f dot is equal to 2 times ds dt. This is constant, Kepler's second law. So if you consider this really weird quantities, it becomes constant. So x y dot minus y x dot equal constant, using the Kepler's second law. Kepler's second law we use. Then one more derivative. So d dt x y dot minus y x dot. So derivative of the constant value is becomes 0. The derivative. This is derivative x dot y dot plus x y2 dot minus y dot x dot minus y x2 dot equals 0. Then first term and third term exactly same terms is going to be cancelled out. Then we have this relation. And then from this equation, we have this equation. So accelerations a sub y over a sub x. So acceleration is directed on these lines. So could be directed outward, could be directed inward. We discovered acceleration is directed toward the suns. So acceleration is proportional to the force. Gravitational force is directed toward the sun. So sun is the source of the gravities. Using the Kepler's second laws, we discovered these relations. Then we are going to derive the universal law of gravitation. So if we use the eccentric anomalies, x equals a cosine e minus ae, then y equals a square root 1 minus e square sine e. So x dot, you can calculate minus ae dot sine e, and the y dot equal a square root 1 minus e squares e dot cosine e dot. Then we discovered first derivative. One more derivative, second derivative of these equations, you will have this relation. So we keep finding the derivatives. Then from the Kepler's this equation. So from that equations, 1 minus e cosine e E dot equal N. So derivatives is becomes E2 dot plus E dot square sine E minus E cosine E E2 dot equals 0. So from these equations we have 1 minus E cosine E E2 dot equals minus E sine E E dot squared. We have these relations. Then return to the equations for the x2 dot. Then we have derived the E2 dot equations and the E1 dot. We have already discovered. Then substitute this relation, and finally we have a x2 dot is a minus n square a cube over r cube x. For the same ways, E2 dot E dot you can substitute for the E2 dot. E2 dot is here, and the E dot you can use these relations. Substitute back to the y2 dot, this one, and then find the y2 dot, express this one. And the fourth can be obtained square root x2 dot squares plus y2 dot squares. Then substitute this equation, and then it becomes n square a cube over r squares. N square a cube, if you apply the Kepler's third law, this is constant value. That's a Kepler's third law. So f is equals the constant over r squares. So we discovered f is proportional to the 1 over r squared. This is inverse square law of the universal law of gravitation. This is the end of this session.